We start from the ComposicaD project menu and go to the Tanks and Vessels section. Under the Mandrel tab, one will specify the number of linear and dome segments. Here one considers how accurately the geometry is described. Before exporting the data, we will re-specify these values to be 100 each. That determines the highest accuracy for the description of the cross-section. While closing the dialog, the winding simulation is rerun. From the Laminate menu, I will pick the Laminate table, and then I use the cross-section tool to visualize the thickness of individual laminas. The laminate table has been previously created and it describes the different steps of the binding process. If we look, for example, the third lamina here, which is between the blue lines, we can observe that the layer thickness may be slightly smaller or greater than the nominal thickness while we go over the previous turning points. Sort of smoothing is needed to guarantee proper mold surface for the following lamina. This phenomenon can be observed later from the FE model. In the laminate table, the thickness of the laminate consists of the total thickness of the lamina pair. If you wind in the plus 80 degrees direction with the nominal thickness of 0.2 millimeters, then the lamina thickness is 0.4 millimeters. That's for helical plies. For circumferential laminas, the thickness equals to the material thickness. For the export, some additional actions are needed. One should notice that these actions modify the native data format of ComposicaD, and this is necessary only for the ESAComp export. Further winding modifications need to be done for the original file, and therefore I make a copy from the current project. Using a Python script, the original laminate table of 18 laminas will be modified. I run a script file provided by Seifert and Skinner. The scripting makes it possible to represent all lamina with positive orientations with unique elements in the true thickness direction of the mesh. The same goes with the lamina with negative orientations. Now the laminate table contains 36 laminas. The actual export is made through the laminate menu by selecting Export to FEA. Export to ESAComp provides means to export the shell-based element model, but now we are exporting the 3D solid model. At first, one opens a template file provided by Seifert and Skinner. One specifies which material is assigned for the resin filler. In this project we have 7 material systems and the last one is selected. Under the Options tab, one sets the parameters for the mesh. 3D rotation increment could be 2 degrees, for example. Some other small angle can be used as well. Then set the thickness threshold. Here the nominal thickness of the thinnest material shall be used as a reference, and then divide this value by 10, for example. For axial segments, use equal element spacing and then the desired element length. With this setting, the extrusion of the mesh is made perpendicular to the surface of the mandrel. Now perform calculation. Please note that after making this video, some details related to exporting the data may have changed in ComposicaD. Please consult Seifert & Skinner or ComposicaD. Finally, select the folder for the files to be exported. Now the export has been made and we can open the original ComposicaD project file, which shall be used if further modifications are to be made.